So we are getting a propane product from here. And the second thing which we are going to get over here, hello everyone, welcome back to PLUTUS STEM. So today we are going to discuss a very important reaction, that are reaction of alkyl halide with metals. So in this reaction we will be discussing various metals such as sodium, magnesium, zinc, copper and lithium, and how they are going to react with different alkyl halides, and what are the products which we are going to get. Are we going to get the even number of products, or you can say even alkane, or even alkyl, or you can say even alkyl halides? What is going to be formed? That all the queries are going to be cleared up after this session of this video, you can say. So those who are aware that we have already covered up the various other reactions such as substitution reaction and the elimination reaction of these alkyl halide in the previous videos, that the links is being provided below over here only. So now coming back to our topic, that is reaction of alkyl halide with metal. So firstly we will be starting with the sodium metal. So if you see over here, what is going to happen in this type of reaction, when alkyl halide, or you can say Rx, react with the sodium metal Na, it will give R. So if we are getting 2R, that means this reaction need to be balanced. We are having 2R over here. Plus NaX is going to be liberated, and again this Na is 2Na. So RR plus 2NaX. So this is the way how we are going to get a product, that is alkane. From alkyl halide we are getting alkane. So if you take an example CS3, CS2X, or you can say Br plus 2Na, we are going to get a product CS3, CS2, CS2, CS3 plus 2Na Br. So how this reaction proceeds, that we are going to see over here. In the first step, this Rx will be reacted with sodium metal, and this sodium, you know that Na gives Na positive plus electron. So this electron which is being liberated from this sodium metal, it will attack at this side. It will attack at this side, and we are going to get, it is going to liberate. So we will get a free radical plus X negative, and we are having Na positive from here, Na positive and electron. So the first step, we are getting a R free radical. So in the second step, what is going to happen, this R free radical will be attacked by another sodium metal. So again in the similar way, this sodium metal will be liberating Na positive and 1 electron. Na positive and 1 electron. So what we are going to get, in this again 1 electron will attack over here, and we will get R negative plus Na positive. R negative plus Na positive. In the final or the third step, this R negative will attack at another Rx molecule or another alkyl halide. It will attack at this center, and this X will leave out from here, and we get an alkane. We are getting an alkane as a product, and the sidely we are liberating X negative, that will interlink with this sodium NaX. So this is the pathway through which this reaction proceeds. So we can very easily see the possibility is that it is going to form an even number of alkene. So if we are having CH3 Br plus 2Na, it gives. So the easiest way to remember this reaction will be like plus Br single band CH3. If you don't need to remember the mechanism, you can just simply do this thing. And this bond is going to form CH3 single bond CH3 plus NaBr twice. So this is the easiest way how we can form this. But if we want to get a odd number of alkane, that is very difficult. Why? I will show you. CH3 CH2 Br plus 2Na plus BrCH3. So in this case, what we are going to do, we will be reacting these CH3 single bond CH2 single bond CH3. Number 1, methane, ethane, propane. So we are getting a propane product from here. And the second thing which we are going to get over here, the second thing will be this ethane over here, sorry. This ethane molecule can self-react with each other and we will get a butane. And in the similar way, this ethane can react with the self molecule and we will get ethane. So there are 3 types of alkane are being formed. If we need to prepare a odd electron species, or you can say odd alkane, or you can say odd alkane. So it is not a good way to form an odd number of alkane. So the best way is to form the even number of alkane. So now we will be seeing another reaction, that is the reaction with zinc metal. In Na we are going to have 2 sodium, because sodium is having 1 electron in its outer shell, but zinc is having 2 electrons. That why when Rx react with zinc, only 1 zinc is being needed and it will give Rr plus ZnX2. This reaction was given by the scientist Frankland, and in this it took the Ri, or if we take a CH3 CH2I plus Zn gives CH3 CH2 CH2 CH3 plus Zni2. So this type of reaction, again the whole thing is similar and the mechanism is also quite similar to this, you can say sodium metal only. In this, only 1 single zinc is going to attack twice, not 2 Na we are using over here. In this sodium we were having 2 different Na, they were providing the electron, but in this case individual zinc is going to provide the 2 number of electron. So in the case of another metal, that is magnesium, and it is going to give a very interesting and important reagent, that is a Grignard reagent. By the reaction of this alkyl halide with magnesium metal in the presence of dry ether, we are going to get a very famous reagent, that is Grignard reagent. So Rx when reacted with Mg, it will give us RMgX. So in this again, how this reaction proceed, Mg gives Mg dot positive plus electron, and that electron will react with Rx plus electron, we are going to get R free radical plus X negative, and this Mg positive and this R dot plus Mg dot X will form RMG. positive, and that will be linked with this ion will linked with X negative. So this is the Grignard reagent RMgX. This is the way how this Grignard reagent is formed. So to confirm that this free radical is being formed, if we are having a product like this, reagent like this plus Mg dry ether, the product which we are going to get over here is benzene. How this reaction proceed? It proceeds through a mechanism like this. These are the free radical, and now we can break down this any bond. And again the bond formation takes place to give a more stable product. That is benzene. And these two are quite same. So this is the way how this magnesium react with this, you can say, alkyl halide. So now we will be seeing the reaction of lithium and copper combinedly. Rx plus lithium. It is a transmetallation type of reaction where RLi is being linked, and when this RLi react with copper, because copper is having two, you can say, moiety, so it will give us RCu positive, or you can say R2Cu Li. This is the way. And now these reagents, these can help us by breaking down. They can form an odd number of alkane. Odd number of alkane. They can produce the odd number of alkane with the help of this copper. So the quiet summary of this today's video we are going to see over here. That firstly we have discussed the sodium metal. It is providing us a alkane, specifically the even number of alkane. Specifically the even number of alkane. Odd number of alkane is not preferable because we are getting enormous number of product. The same thing is being carried out with the help of the zinc metal, and the reaction when this iodine is taking place termed as Frankland reaction. This magnesium is giving rise a very important reagent, that is a Grignard reagent, and this lithium give RLi, and when it reacts with the copper, we are getting R2CuLi, that can give rise to those alkane that are odd numbers. So that's all for this reaction of haloalkane. In the next upcoming videos, we are going to discuss regarding the various reactions of haloarine. Thank you. Have a nice day.